part two of this video. So let's take a look at some more examples here. Okay, again, same process. We're going to factor the numerator and denominator. When I look at the top, I can see I have a common factor of 2. So that's the first thing I'm going to take out. So I'm left with an x squared minus a 3x minus 4. And on the bottom, I have, it looks like a perfect square to me. Let me take my magic pen. So I have x, I have 4 for those square roots. So x times 4 times 2, does that equal 8? Well, I think it does. So that is a perfect square. And if you didn't see that, you can factor it the normal way as well. So x minus 4 squared. Okay, so I'm still not quite finished here because I can still factor more in the numerator. However, I can see my restriction already in the denominator. It is x cannot equal positive 4. So let's continue factoring. And we're left with an x, okay, two numbers that multiply to give me 4. They subtract to give me 3. And the largest one is a 3. And we can see that we're going to have a negative 4 and then an x plus 1. And all of that, again, is over the x minus 4 squared. Now, you don't have to put the restrictions again for each line. As long as we put them once, it carries down until we're doing the last part. So now I'm looking for anything that is in common between our numerator and denominator. And you can see that brackets, if I'm going to cancel out brackets, the brackets have to be identical. So this x minus 4, you can see that it's exactly the same as this one down here. So I'm left with just a 1 here. So I'm almost finished. We just write down now 2 bracket x plus 1, x minus 4, and x cannot equal 4. Now you can't cancel these x's that you see in the denominator and numerator because they're held together by brackets. They're held together in the bracket by adding, okay, and subtracting. And you cannot rip something apart, a common factor, with adding or subtracting. It has to be multiplying or dividing. Okay, so let's go and take a look at another one. You can see they can just keep on coming, and the only difference being is how much factoring work you're going to have to do. Okay, so it looks like someone was at least a little bit nice to us and did some of the factoring. So we have an 8x, and then also on the top we have two numbers multiplied to give me 2. They subtract to give me negative 1. Okay, so I know that's going to be x minus 2, x plus 1. And my denominator, I can see that in the first bracket I have a 16 as well as an x that's in common, and when I factor them out I'm left with an x plus 1, and then I'm left with this last bracket, which is a difference of squares, x squared minus 4, so that's going to be x minus 2, x plus 2. And now I can state my restrictions. X cannot equal, now we have quite a few here, so if we start with the first one, it's 0. Oops, that was crazy. 0. The next factor, so a negative 1, and a plus or minus 2. Okay, so sometimes you can have quite a list of restrictions. Now, almost done. So this is the fun part. This is the part I always like, is because I can pick up different colors and can start scratching stuff off. And if I take a look at, I have an x minus 2, I have an x minus 2, I have an x plus 1, and x plus 1, and then I'm going to the number part. So let's see what else I have here. So hold on, I want this to move so I can, I guess it's not going to work. We have an x, and then I have an 8 and a 16. So when we look at them, for instance, 8 goes into itself once, 8 goes into 16 2 times. So we're left now with a lot of things stroked off, so it's just a matter of us going and seeing what we have left. Well, on the top, I don't have anything, which means I really have 1 there. On the bottom, I have a 2 and an x plus 2. And now I also need to state my restrictions. X cannot equal 0, negative 1, and plus or minus 2. Okay, so If after you've done all the factoring and you can't cancel something out, it's probably because you maybe factored incorrectly. One more comment that I'm going to make about this lesson is equivalent functions. Now, I'm not going to do an example of equivalent functions because really what it means is you're just simplifying something algebraically. So to determine if two expressions are equivalent, just simplify to see if they are algebraically the same. So in other words, if I take my line before something is factored and then something after it's factored, they look different. Okay, but algebraically they're the same. So how do I prove that? It means that I would expand both of them and demonstrate that they are identical. Okay, some questions for you to do and have lots of fun.